Thank you. Okay, so thank you everyone for attending this presentation. My name is Tom Carlitos, and I will be presenting on behalf of the PyGeoAPI Project Steering Committee. One of the Project Steering Committee is with us. That's George, who's in row 2. Thank you, George. So yeah, let's talk about PyGeoAPI. I will give an overview of the project, and we'll discuss core capabilities of what's possible. I'll discuss latest developments. We recently had our latest release, so we can discuss what's been implemented there. We'll look at some selected featured projects. There are a number of deployments out there, and we'll focus on a few of them for the sake of the presentation, and a bit of a roadmap into the future on what on other things that we're planning on implementing and supporting. So, what is PyGeoAPI? PyGeoAPI is a OGC API server implementation. So how many people are familiar with OGC APIs? Great. So it is a server implementation of those APIs. It aims to support all of the OGC API standards as they evolve. It is an OSGeo project. It was given that status in 2022, so we're really happy to be an official OSGeo project and be part of that community, and it's been around since 2018. It's a web API framework, again, for OGC APIs, and it does, given the fact that it implements OGC APIs, it does REST, JSON, OpenAPI, Swagger, and these things that are supported by the standards. It is certified, OGC certified compliant on a number of specifications, and actually the reference implementation on a number of those specifications as well. So its support for OGC APIs is quite strong. Again, it's an OSGeo project. We have quite an international team across a number of different countries and time zones. So sometimes project steering committee or committer meetings might be challenging with regards to time zones, but we make it work one way or another. And we have numerous core contributors in addition to our project steering committee, of which George is one of our PSC members. So we stand on the shoulders of giants, as you can see, given that we use a lot of packages from upstream that you've probably heard about this week, whether they're GDAL or Proj or GEOS or other types of FOSS4G software. Pretty easy install if you want it to be. You can install it in 5 minutes or so. So there's a basic workflow that is actually on our website. So if you go to pygeoapi.io, you can copy paste that, give that a go, and you can get a minimal install working. It is very important to the project to have a minimal install capability so that you are up and running. And this is actually running it without any Docker or any containerization. This is straight on your laptop if you want it to be like that. Of course, you can scale that out and have a more elaborate setup, which we'll talk a bit more when we start talking about deployment options. It's a core API. It's agnostic to web framework, so it's built in Python. So Python is the programming language used to provide the API. In Python, we have a number of different web frameworks, such as Django and Flask, or if you want to do things asynchronously, there's things called Starlette and so on. So it is very agnostic in that it can support many of these web frameworks. So we support many web frameworks. We have a very simple YAML-based configuration. And by doing that, we are leveraging all the neat things that YAML can do for you. So if anybody ever worked with YAML? Cool. So you know that you can do anchors and references in YAML and have things that, very powerful constructs that you can reuse without copy-pasting all the time. So that's one of the reasons why we're using YAML as a configuration format. In the same way that we have YAML as a configuration format, you can start PyGeoAPI without an actual YAML file on disk. You can run it with a Python dictionary that is built somewhere in your middleware, and you can send that along just the same. So very flexible in terms of how you can deploy the thing, and it will stay out of your way if you want it to. We support OpenAPI because OGC APIs support OpenAPI, and we have a very, I would say, specialized way to put that all together by going through all the different data sets and generating, I would say, a fulsome OpenAPI document with all the information that's needed to bind to data for a Swagger page. Anybody heard of Swagger? Yeah, exactly. A lot of PyGeoAPI is built on plugins. So the basic idea here is in a way, it followed the way the new generation of OGC specifications are being developed. So the first generation of OGC specs, it was sort of all or nothing, where you either implemented the 200-300 page specification, and I see some of us here who have all the scars of doing that, as opposed to the OGC API era of specifications, which are more modular, and there is a core to the specification, and then there are a number of extensions, and we tried to follow that same approach in the project. Let's hope this comes back. Right. We tried to follow the same approach with having plugins. This could mean plugins for serving specific types of data or databases or other APIs, but we'll get into that a little bit later. It's relatively easy to install, again, and deploy, whether it's through pip or Docker, or if you want to OpenShift or something Kubernetes. There are a number of different options, or if you need a straight-up apt-get install, it's available on Ubuntu GIS just the same. We try to bundle the entire project with minimum core dependencies to get you started. At some point, as you get more involved in the project, you will want to, you will probably want to extend that a bit more, because you want to support maybe bigger data sets and other types of repositories, but we want to get you set up quickly so that the user entry is very low barrier. That's super important. Diagram, I know this is a little bit hard to see, but the basic way it works is that we have our core, which is naturally in the middle. We take a configuration file, which is this YAML I mentioned, where we generate an OpenAPI document from that, and then we start up the server through this mechanism here, and then that server is made available to any client, whether that client is a web application, a mobile application, QGIS, or any other type of decision support system. This is typically what you would get when you publish an API. Underneath our core, we have a plugin concept, and that plugin concept allows people to write their own processes. So if you're familiar with OGC API processes or web processing service, we have a whole plugin framework for that. If you want to serve data and you want to provide multiple different output formats, we do provide some out of the box, but you can extend those as you wish, as well as providers, which is what we have the most of, which are the actual data connection pieces underneath. As with all the plugins, we have a default set that come with the project, and you can use those if they work for you. If you do want to extend and write your own, you can do so. You can either propose it to the core, or you can manage it on your own. Just the same. So out of the box, we have a number of different providers. One of them of interest is GDAL, which basically supports hundreds and hundreds of geospatial formats. So we support that out of the box. We also have drivers and plugin providers which do not use GDAL but are used directly. For example, I work on primarily the Elasticsearch one, and that is direct access to Elastic. There's some requirements for us to do that, and so we offer those. So you can use direct plugins, or you can use a GDAL plugin to support any raster or vector data connection. For coverages, we are using Xarray. Are people familiar? Anybody familiar with Xarray or ZAR? That kind of big data crowd. So we support Xarray and Rasterio, which is GDAL underneath. Tiles, records. If you are doing bridging, if you have a web map service or a web feature service or a first generation OGC service, you can use what we call our facades, which allows you to put pygeoapi on top of your WMS or on top of your WFS and make it look like a new age API. So that is valuable for change management and migrating users across from the first generation specifications to the current ones. You can also implement your own. Again, you can have you can request for these to be added to the project via a pull request on GitHub, or you can manage it in your own repository, and the two can live on their own quite easily. Processes, if you want to do specific workflows that don't quite fit in the OGC API maps, features, records, tiles, etc. world, you want to write your own custom process, you can do that. This is where you actually require Python knowledge if you're going to deploy pygeoapi with a custom process, because you need to write Python to actually do the thing. So again, different ways of contributing plugins to the project. We also have a pluggable way to do APIs. So you can implement your own API, which may be an OGC API or maybe an ad hoc API that your organization may want to add support for. So you can do that or have it added to the core via pull request, or you can just manage it on your own and have that available just the same. A lot of organizations, from our discussions, have deployed PyGeoAPI with OGC APIs, as well as maybe their bespoke or additional business APIs, which are not really OGC things, but they want to have it available through the same deployment. So this is possible. We have a wiki page with a number of plugins and themes. One thing I should mention is that we're able to do, because the OGC APIs are doing HTML, a lot of HTML these days as a feature, you are able to do your own look and feel. So we have a GitHub wiki page with all the different plugins that are made externally available outside of PyGeoAPI, as well as themes or skins. One day this will be a little bit more elaborate with a search, and we might have plugins.pygeoapi.io. But at this point, I think it's early days. And we support schema.org and linked data and structured data search in support of providing more valuable search experience and search engine optimization. The one thing that's valuable with PyGeoAPI, because of the OGC APIs, is that they are much more amenable to search engine optimization and indexing by mass market web browsers. So we get that happens out of the box when you deploy something with the project. Number of different ways to deploy it, as we can see. Core capabilities. So this is our default landing page. Again, HTML is supported in OGC APIs if you want it to be. So we provide a basic HTML representation. You can customize this as you wish and come up with your own skin or look and feel. Here's a screenshot of our OpenAPI capability, which comes with the project. We support OGC API features, so this is basically raw access to vector data. You can hook up your vector data and make it available to the API. Keep in mind that underneath this all is JSON coming back, or GeoJSON, that is made available to the user. We support OGC API coverages for gridded data or continuous data. There's some coverage data that you would see on the side, and we support coverage JSON as well through OGC API coverages and EDR, which I'll talk to a bit more later. We also support metadata, the OGC API record standard, which is the discovery and search standard for OGC APIs now, and that is supported also out of the box. Here you can see a screenshot with QGIS, which supports OGC API records, that we support that out of the box as well. We support OGC API maps, so whether you have vector data or raster data, you should be you can visualize it and serve it up as an actual map. So this is OGC API maps supersedes WMS in the OGC world. So this is the new WMS, which is called OGC API maps, basically. So we support that. Tiles, if you need some caching and so on, and more performant capability. We also support OGC API processes, which can do ad hoc processes defined as per your requirements. How many people have heard of OGC environmental data retrieval? EDR. So this is a brand new OGC specification that never had anything like it before. It started off as a specification mostly for weather data, but it's come to evolve to support many different types of environmental data. I realize that can be quite a big umbrella, but we support EDR. So for example, if you have NetCDF data, or if you have numerical weather prediction data in NetCDF or something else, EDR is quite a nice API for that. So we support EDR primarily through using something called Xarray, which allows you data cube access and exploitation. STAC, we support the STAC, either a crawlable static catalog or through a STAC API. A bit about templating. So here's a PyGeoAPI install from GeoConnects in the United States, and they've created their own look and feel. So this doesn't look like anything like the previous screenshots, but it is another organization in the US making look and feel. So it's pretty flexible that way. If you have requirements for accessibility or other requirements in your organization that have look and feel requirements, you can pull those off with our HTML templating. We also have an admin API, so you can actually manage the pygeoapi configuration through an API, through an admin. And if you don't want to touch YAML, for example, you can use the API just the same. Latest developments. I'm going to speed up a bit here. We continue to have monthly meetings for the project. They're open and online, and anybody can join. Please check out the link when you see this presentation in the proceedings. We participate in a number of different OGC sprints and OGC API sprints over the years, and we continue to. There was actually a sprint in October in Rotterdam in the Netherlands, and I know there was some GeoCat representation there working on OGC API joins, so that was very valuable to see. But definitely a lot of collaborations happens at these sprints to help us not only move the software forward, but try to find issues with the specifications and try to move the specifications forward just the same. So I think this is a really nice complement of open source software, OSGeo software, working with international standards organizations such as OGC. And anybody that wants to see an update on OSGeo and OGC, please come at noon for the next talk on that collaboration. Compliance updates. These are all of our compliant implementations in pygeoapi. We also added a number of new plugins in the last release or two around different backends, whether they're features, feature data, or metadata, or tiles. Yusuf from Egypt has added support for Arabic, and this is greatly appreciated. So we're glad to have right to left rendering in our UI. We refactored all of the querying and filtered underneath to use something called pygeofilter. If you have needs for filtering in your Python-based project, this is the go-to project. It's extremely powerful. So we refactored it all, which meant we ripped out a whole bunch of code out of pygeoapi and are just using pygeofilter instead. So Leo Gignoni added support for, that was a pull request, so we welcome contributions for GeoParquet, so we're very thankful for that. We added support for data limiting, so this means data set by data set. If we have default limits and then we have maximum limits, so a way for you to control how much data the user is asking for and whether you want to throttle that response or provide an exception. A number of different updates. I'm just going to scan through these. Our next release is in February. That's our 0.23 release, so we're looking forward to that. Some recent projects. So from the Pacific community, we have something called the Ocean Data Management System that provides access to metadata for all the oceanographic data sets in the region. So they are doing that through OGC API records. So thank you, Devesh and team, for pulling that off. And you can see some metadata goodness here coming through pygeoapi. So very happy to see that from this local community. Australia also has deployed pygeoapi through their Geoscience Australia Linked Data Register. It's also available, which is valuable. In the UN, in the World Meteorological Organization, we have updated our data exchange systems to something called WMO Information System 2, or WIS2, and we have a reference implementation called WIS2 in a box, which has pygeoapi underneath as the API. So this is currently installed in over 60 mission-critical 24/7 deployments across the world. There's a significant install base, and it feeds real-time weather data exchange and publication. And last but not least, good work from Portugal and Joanna, who's one of our developers, and they've deployed pygeoapi for a number of different standards. Also our colleagues from Spain. So shout out to them. Roadmap, we will implement OGC API PubSub, so publish, subscribe. That is event-driven architecture. We did some sprinting on this in April in Lausanne, Switzerland. So now that there's actually an OGC PubSub standard that is evolving, we will implement that in pygeoapi just the same as part of either the next release or the release after that. We are also implementing OGC API Processes Part 2, Deploy, Replace, Undeploy, or DRU. The basic idea of this specification is allowing a user to send their code to be executed by a pygeoapi server. This is a whole, the paradigm here is bringing the user to the data. Sometimes the data is too big and I don't want to download gigabytes of data to run my little Python script on it, so I can Dockerize it instead and send my script over to where the data sits. Obviously, there's security considerations and issues around authentication and authorization. We are not covering that in pygeoapi as a rule, but that capability exists. And that, if you've heard of something called EOEPCA, they support this specification through the Zoo project, which is another WPS or processing server, and we're looking to implement this just the same. We have some initial work from last year that needs to be finalized. We will also add some capability for doing site testing through GitHub Actions. So Ricardo from Portugal has added something called OGC Site Runner. I talked to that earlier today, which is basically a GitHub action that you can put into your GitHub repository, and it will run the site team engine for you live against the content of your server, which is resulting for the pull request. What else? Authentication. All we're going to do with authentication is pass through the HTTP authentication header. We have heard that will be valuable for some custom processes which need to do some authorization underneath. So we will do that. And more OGC APIs. I did not mention OGC API joins, which is being developed by GeoCat, but that will be part of a future release as things move forward. And we're looking at implementing moving features and other specs. So we continue to move forward on the OGC API implementation in this project. We do not have an administration UI. The project is headless by design. We welcome any contribution on anybody that wants to build out an admin user interface. I know there's been a number of different implementations and examples. So Krishna, I think, who's in the room, has implemented one. So anybody that wants to see that, get in touch with Krishna. Actually, he's not in the room, but get in touch with him just the same. You'll see him at today's closing plenary. We have support services from GeoCat and other organizations, so you can go to our service provider page if you need support. That would mean either deployment or core development or anything related to the project. So we have a service provider list just the same. And we have t-shirts. We didn't bring any here, but they're available if you wanted to buy them from the OSGeo shop. There are some quick links. I think I went a little bit over time, but I want to thank you for your interest. Hopefully this was a valuable overview of the project and where we are and where we're going, and thank you for your time.
We've got time for a few questions. Does anyone have any? Anything else?
This is also a previous slide question. Could you show the previous slide where you had the GeoParquet contribution to take a picture?
No problem. I better see these pictures online, you know.
Not with you in it.
No, of the contributions by the community.
I did meet Leo